The Earth is not a motionless planet. Its crust bends, breaks, and moves, and those movements leave behind a record written in the rocks. This record is the language of structural geology. Today we learn how geologists describe the architecture of the Earth in English. Part 1. What's structural geology? Structural geology is the study of the formation of rocks and the structures produced by tectonic forces. Those forces can compress, stretch, or shear the Earth's crust, and they create the structures we observe in the field. Part 2. Faults. When rocks are subjected to compression, they may bend without breaking, forming faults. Key vocabulary: fault, anticline, syncline, fault axis, and limb. Example: the sedimentary layers are folded into a large anticline. Faults can reveal the history of tectonic deformation and may create traps for valuable resources. Part 3. Faults. When stress exceeds the strength of a rock, it fractures and moves, forming a fault. Key vocabulary: fault, fault plane, hanging wall, footwall, and displacement. Common fault types include normal faults, which result from extensional tectonics, reverse faults formed from compressional tectonics, and strike-slip faults, which result from lateral shear stress. Example: the ore body is controlled by a major shear zone associated with a strike-slip fault. Part 4. Fractures, joints, and shear zones. Not all fractures show movement. A joint is a fracture without noticeable displacement. A shear zone is an area of intense deformation where rocks have experienced significant shearing. These structures are extremely important because they often act as pathways for hydrothermal fluids carrying valuable minerals. Example: quartz veins occur along fractures within the shear zone. Part 5. Structural analysis. In mineral exploration geologists do more than identify structures. They analyze their orientation, geometry, and relationship with mineralization. Important terms: strike, dip, lineament, and structural trend. Example: the dominant northeast-southwest structural trend controls the distribution of gold-bearing quartz veins. A professional geologist might say, "We identified a network of faults and fractures associated with a regional shear zone. These structures acted as conduits for hydrothermal fluids and controlled the emplacement of mineralized quartz veins." This is the language of exploration geology: precise, professional, and scientific. The Earth speaks through its structures. Every fault tells a story. Every fault records a force, and every fracture may guide us toward a discovery. Learn to read the architecture of the Earth, and you will learn to understand the processes that shaped our planet. I will see you in the next lesson.